is a huge application for us because we live on the coast, and I don't know how much you go to the beach. I go to the beach a lot. I don't necessarily go in the water as often as other people, but rip currents are a big deal in our area, and so we need to understand the geometry behind it because it could save your life if you're out swimming and getting caught up in it. Just remember, one thing you don't want to do is you don't want to fight the rip current. You don't want to swim against it. It's gonna win every time. Rip current 1, you 0. It's gonna win. It's too strong. And so to get out of a rip current, you need to swim parallel to shore. And once you feel that you're out from the pull, then you can turn around and start heading back to shore. Okay, that's the mistake that a lot of swimmers make, and then they get wore out and then they drown. And so it's very important. I hope this is life-saving information for you, and it's very important, especially in our area. All right, now let's apply it. Rip currents may be caused by a sandbar parallel to the shoreline. Waves cause a buildup of water between the sandbar and the shoreline, and when this water breaks through the sandbar, it flows out in a direction perpendicular to the sandbar. So that's why you get sucked away from shore. Okay? So it's a perpendicular kind of breaking through that sandbar, and it forms perpendicular lines there. Okay? So they're asking you, why must the rip current be perpendicular to the shoreline as well? So if you kind of do a basic drawing, here's the sandbar, okay? Here's the shoreline, and what we know about them is that they're parallel to each other, okay? Your rip current is perpendicular, so we can call that a rip current right there, and it moves very swift, and it's very scary when you get caught out in one and you feel yourself getting sucked out away from shore. That gets really scary, especially when you can't touch. All right, so we're not going to panic because what we know is that we can swim parallel to shore. Get your eyes on the shore and get yourself parallel and start swimming that direction. No matter how far out you are, just swim in that direction, parallel to the shore, and then you can swim back in. Okay, to finish this problem, why must the rip current be perpendicular to the shoreline as well? If it's perpendicular to the sandbar and the sandbar is parallel to the shoreline, then why does the rip current also have to be perpendicular to the shoreline? What is it that can prove that this is true? That if I extend this line all the way to the shoreline, that this has to be true as well. Why is that also true? Think about your theorems, and hopefully you're thinking, oh, because of the perpendicular transversal theorem. Remember what that says. If I have a transversal that's perpendicular to one line, and that line has a parallel line, then that transversal is also perpendicular to the other parallel line. So that's the reason why. All right, so let's look at this one. A swimmer who gets caught in a rip current should swim in a direction perpendicular to the current. Why should the path of the swimmer be parallel to the shoreline? So we talked about that. Safety, that's what you do if you get caught in a rip current. But why geometrically? Give me a geometry reason. Give me a reason why that is true. Okay? Good luck with that, and bring your questions to class.